Hello, welcome to snow day number 2. I wanted to make a quick little video to give you instructions on today's assignment, as long as today's assignment works out as planned. As you know, we've been graphing a lot in class lately, so I was trying to find a way that you could graph virtually. I hope I figured it out. We'll see. I'm going to quickly go through 2 graphs with you. Now I'm going to do them quickly, so if you have missed class for whatever reason, and these 2 examples are not enough, obviously you should go back and watch videos from Monday, Tuesday, and Wednesday of this week when we talked about graphing polynomial functions in more detail. But for this assignment, here is what I'm going to ask you to do. I'm going to give you a scenario like we've been doing in class on that whiteboard website. The same idea. I'm going to give you a scenario and you are going to graph that function. So for example, if I'm asking for a degree 2 polynomial function with a negative leading coefficient and a positive double root. So a lot of vocabulary to unpack there, right? But as soon as I see degree 2, I'm immediately thinking of a parabola. So it's either this shape or this shape. I keep reading and it says it's a negative leading coefficient. So now I know it's a parabola that opens down and it has a double root. Now that was something we talked about in class on Wednesday. Those double roots are going to look different. Instead of going through the x-axis, they're going to turn and touch at that x-axis or be tangent to the x-axis. And then this little detail saying that it's a positive root, so it doesn't tell me exactly where, so you don't even necessarily need those tick marks on your graph. As long as you put the root somewhere over here that's positive, and then make that a double root by turning around at that spot. Now I'm doing this with a stylus. I know you'll be working at home with a stylus or a pen on your touch screen. Or your finger even. So it doesn't have to be perfect, but we've got the gist, right? We know what degree 2 makes a parabola, so we know the general look. We know negative means it has to open down, and then we see this idea of a double root where the x-intercept is also the turning point. So you'll be given some scenarios where you'll graph a function like that. You'll also be given some equations. So the equation, we could be a little more specific. So when we make these graphs, you will need to include the tick marks on your x-axis at least, so that we can, as you see, clearly label the zeros of the function. So this is what we talked about in class on Wednesday. What's nice about this form is it's in factored form, so we should be able to set each of these factors equal to 0. So I have 1, 2, 3 x's in the problem, so I know that the degree is 3, right? So I know that general shape of a degree 3, but wait, I also see that it's a negative, so flip that, and it's going to be the degree 3 that opens down, right? So I can erase that original thought, and I need it to open down. But then more specifically, I can also label where it crosses the x-axis by setting each of these x's equal to 0. So the first x equals 0, of course. The second, if I solved x minus 2 and equal it to 0, then I'm going to get x equals positive 2. And this is work that a lot of you can do in your head, right? So on your Jamboard assignment, you don't even have to necessarily show that work. So all I'm going to be looking for are your graphs. Just make sure your graphs include all of the detail. So the graph needs to cross at 0, needs to cross at 2, and needs to cross the x-axis at -5. And those are just single roots. So nothing fancy, no double roots going on here. We can just start up and cross, cross, cross to make our degree 3 shape polynomial. All right, so it's not perfect, but you get the idea, and I'm not going to expect perfection from you guys either, but I'm going to ask you to try sketching 5 of those. So here's what I'm hoping works, is I hope that I've shared a Jamboard for you correctly that you can edit. The first slide just kind of, again, is giving you the instructions, and then there should be 5 slides, 2 of which are just giving you a verbal description, so you can just make a pretty generic graph as long as it meets the requirements of the description. And then there are 3, right? 1, 2, 3, where you have the equation, so you can be a little more specific with your graph and make sure that you label the zeros of the function on that graph. So that's going to be shared to you under the classwork tab. As always, you should have your own copy that you can come over here. This is, I have it on marker. You can change it to pen. And then you can draw, woof, right? From there. Doesn't have to be perfect, but make sure you include your zeros and you get the end behavior and the general shape of that function correct. All right. It'll be great. It should be short and sweet, and we will all be back together happily on Monday. I look forward to seeing you then.